What's up, my printer peoples? In this video, I'm going over a classic, which is E3D's V6. Now, they've made some updates and made it even better, so let's check it out. When you get the package in, you get a Bowden tube and your signature baggie full of parts. Just pop this thing open. So the green baggie always has the heatsink and metal parts, and the other baggie has electronics. Now, if you got to see my other video up here about the volcano, you noticed that I had an issue with confusion over 12 or 24 volt parts. This baggie has a sticker, 24 volts, no confusion. I like this. So far, so good. You get a fan for cooling, 24 volt rated, perfect. The shroud that bolts to that to keep air flowing, good. You get a hardware kit that has the screws and some tools to put everything together. A zip tie for organization. Now, this is one of the big changes with the V6 now, is that they now have a thermistor cartridge. It's still the 100K Semitech 104 GT2 thermistor that's good up to 300 degrees Celsius, but it's no longer just a glass bead that you have to carefully bolt into the block. It's now a heater cartridge that's a lot more durable. You just shove in there and put a grub screw against it and you're set. So this is a great design change. I like this. Also, another big change is that they've gone from a 40 watt to a 30 watt heater cartridge. Now, I talked to Sanjay and he said the big reason for that was that they found a different supplier that had better quality heater cartridges, and they didn't want to accidentally allow the 40 watt to get so hot that it would melt aluminum, or the 40 watt was capable of melting aluminum. So since the E3D is made primarily out of aluminum, that's no good. So this 30 watt still has plenty of power to melt any filament you want, but it's not capable of melting the aluminum parts, which is kind of a safety feature, which I welcome. And then of course your wiring harness to connect to the thermistor and the cooling fan. Alrighty, let's shift all this over. Let's take a look at the second baggie full of goodies. Okay, so the classic heatsink. Man, this thing is pretty. I noticed some chatter up in the 16mm mounting groove, but other than that, I mean, this is a very pretty looking, there's no sharp edges. They just do a great job manufacturing that. Thumbs up to you guys. And then a Bowden quick connector, because the Ultimaker that I use obviously is Bowden driven. And then this last small baggie contains the heat block, heat break, and the nozzle. So another thing that I've noticed that's different between this newer version of the V6 and the V6 that I got a while back is that they're now including heatsink compound, and they're asking you to put that compound on the top end of the heat break that mates or threads into the heat sink. You do not put thermal compound on the bottom side that threads into the heater block. I'm probably not even going to bother with the thermal compound because it's a mess. That's what you get with the new V6. There's definitely some new stuff. Let's go ahead and assemble the V6 before we take it over to the printer. First things first, look at the heater block and find the side that has the two smaller holes on either side of the main hole that the nozzle threads into. Go ahead and thread the nozzle all the way down until it's flush, and then back it out 3 flats. There needs to be a small space between the shoulder of the nozzle and the heater block. Then we're going to grab the heat brake and thread it in until it jams against the nozzle. Now this is hand tight, don't crank on it yet. Next, we can grab the small grub screw and go ahead and thread that into the block above the nozzle. Use the given tool to go ahead and thread it in the majority of the way. Don't thread it too far in, otherwise you won't be able to slide the thermistor all the way through. You want to make sure that it can slide easily to the other end. Once the thermistor is in place, go ahead and finish tightening the grub screw to clamp down on it and make sure that it won't come loose. Take care not to crush the thermistor cartridge. The grub screw easily bites into it. Now we get to install the heater cartridge. Make sure and get the middle of the heater cartridge lined up with the middle of the block. It's going to stick out of either end, but that's okay. The heater cartridge requires a lot more oomph to tighten than the thermistor. You have to deform the aluminum heat block to clamp down around the heater cartridge. So don't be afraid to give a little oomph, because you want to make sure that the heater cartridge does not slip or rotate in the block. I know I said I wasn't going to use the thermal compound, but I figured I might as well show y'all how to put it on. Instead of tearing into the bag like a savage like I did, I would recommend maybe getting some scissors and cutting a corner off so you can kind of squeeze it out where you want it. I had a hard time getting just enough out where I wanted it because of the massive tear. It was kind of a mess. But you can go ahead and see that when you put it on, I put on way more than I actually needed. So a little bit does it, and don't overdo it. There's a lot more in the little bag than what you need. Once you've got the thermal compound spread evenly over the heat break threads, grab the heatsink and thread it on. You'll see that because I put too much on the heat break threads, it begins to squeeze out and pool on the bottom of the heatsink. But that's okay because we can wipe it off. It's not that big of a deal. Just remember, don't put very much on. That's it for the assembly of the V6. Now we need to go over to the printer to prep it for installation. All of E3D's hot ends use a 16mm groove mount, so make sure that you have a print head that accepts that. And if you don't have one, go ahead and print one before you tear all the electronics off your printer, because then you're stuck. Alright, so we're looking at the top of my Ultimaker, and we're going to have to do a couple things before we can install E3D's V6 the way they want to. So Ultimaker comes with a thermocouple, and I'm going to use E3D's thermistor. I need to take off this cable that goes to the amp chip for the thermocouple. Loosen the thermocouple wires and then pull the amp chip off. I'm not going to be needing this anymore. Now the thermocouple allowed me to go to higher temperatures than this thermistor. But I'm going to try, I've never tried E3D's thermistor combination with their hot end, and I'm curious, and I just wanted to show you all the entire process of installing everything. So I'm doing it the way you should do it if you don't have anything else set up already. This is the thermocouple, and this gets tossed in the bin for when I want to use it next. So now we have my print head that can accommodate the V6 and the fan and everything as if this is a blank slate and you just are putting things together. I'm going to go ahead and suggest that we put the fan on first. Let's figure out what direction does it blow. It should say, it doesn't say. Oh man, can we test this real quick? Alright, so it blows out the direction that the sticker is. The air passes through the backside in that way. So I'm going to go ahead and line it up so that the cable is naturally wanting to go up and out. So it's going to be easier if we start these screws poking out a little bit. You want to make sure and get the fan as close of a fit to the print head so none of that air escapes. Because any air that's not going past heatsink, you're cheating yourself out of ability to keep the hot end cool. You're going to want to route your wires the way that you see best fit for your specific printer. For me, I'm going to go off to the side because of my Ultimaker. Alright, we take these two screws that were the two extra screws that I didn't put in the fan, and I'm going to use them to clamp Phillips the hot end into the print head. Alright, we can test that. We'll bring this over here. So that is loose because we haven't torqued it down all the way yet. The hot end itself does not move inside the print head, so that's good. So now we just need to route the wires for the thermistor, the fan, and plug in the heater cartridge. Alright, now that we've got the Ultimaker flipped over, these are the two wires that came off of the V6. I went ahead and labeled one fan, and the other one I know is the thermistor, so that's going to avoid some confusion later on. So now we just got to figure out where these go. The ramps board that we need to get to for all the connections is underneath this Ultimaker cooling board that I made. You can check out the video of me designing and making this here. These ribbon cables just go to the main display, so we can pop those off. Alrighty. You can see that I already have a thermistor set up with only 2 wires. Now the thermocouples that come stock on the Ultimaker have 3 wires each. Now that's okay because we can still use the same connections but use a thermistor. We just have to make sure and use the signal and the ground pins. You'll see here that there's a resistor that I had to solder in for my heated bed to work. So I'm also going to have to solder in a 4.7 kilo ohm resistor right here so I can get temp 2 to work. Or temp 1, I'd solder in the resistor right here. The third bundle of wires on the opposite side of the board controls the PWM signal going to the cooling fans that cool down the print. This is not to be confused with the cooling fan that goes on the E3D hot end. That needs a constant 12 or 24 volt supply. Okay, let's get that 4.7 kilo ohm resistor soldered in place for the temp 1 sensor. There we go. Now we need to connect the thermistor cable to the connection here. But here's the tricky part. We've got, what is this? This is the signal. This is a constant 5 volts, and this is ground. So here I've got ground and I've got my signal. So I need to figure out a way to separate those two. And I'm going to do that by replacing the plug-in with a plug-in from a servo. I'm just going to pull up these retaining clips and slide out the connector. I can push these in, making sure there's a space in between them. So now that is connected, and we should be able to get the thermistor reading working as long as we modify our firmware. So this is where I had my fan previously wired. I'm just going to unplug that. And that goes there. So the second I turn on my printer, that fan's going to turn on and start cooling down the hot end, which is what I want, so that's good. I think that's it. So now we can just go ahead and hook up these cables back the way they came. Both fans spin freely, there's nothing hitting them, so that's good there. All right, let's flip her over. To accommodate the short heater cartridge wires, I've got a jumper from the main board with an XT60 connector. E3D's included wiring for the thermistor and the cooling fan just aren't long enough. That's okay, I didn't really like those bulky connectors anyways, I'll just make my own. Getting the heater cartridge to work with my printer using the XT60 connectors is quite easy. All I need to do is solder on an XT60 connector to the blue heater cartridge wires. Once the connector is soldered on, I go ahead and check the resistance just to double check that I'm putting the right cartridge in with the right settings. Yes, it's 19 ohms, so that looks like a 30 watt cartridge set up for 24 volts. So I go ahead and get my permanent marker and write on the connector what I measured. That way I avoid any confusion in the future. Because I'm a little obsessive compulsive about wires and I don't want to use any more than I absolutely have to, I decided to share a common ground between the fan and the thermistor. That way I only run 3 wires up the Bowden. This creates a very low profile and clean looking wire bundle in the print head. Now we need to plug it in and update the firmware to adjust it from using a thermocouple to using a thermistor. If you're not quite sure how to do this, click on the link and I explain briefly how to get to the point where you can modify the Marlin code. Now we scroll down to where the temperature sensors are and we notice that the number 5 in this list is the 100K Semitech 104 GT2 thermistor. Perfect. So now we scroll down a little bit more. We change the -1 to a 5 to change from the thermocouple to this thermistor. Now you need to upload the firmware to the printer. Before you update the printer, you'll notice that you'll get a max temp error because it's thinking that it's a thermocouple connected, but really it's a thermistor. So when you upload the firmware, it should do this and then it should show you the correct temperature. It's crucial that your temperature sensor is working before you run the PID Auto-Tune. Click the link here if you want a more in-depth description of what I'm doing with the PID Auto-Tune. But basically, I'm setting the standard M303 S230C8 to get the hot end to do the PID Auto-Tune to a set temperature of 230 8 times. So now we're just going to sit back and let this sucker cycle. After the Auto-Tune has run its black magic, go and grab the last PID values that it spits out. Take those over to your Marlin firmware that you've already adjusted and put them into where it asks for the PID values for the hot end. Once you've adjusted those, save it and upload this new firmware again to your printer. But wait, there's more! Now go to your printer, and after you've uploaded the firmware, go into the menu and go to Control, Temperature, and look at the PID values. You'll notice the PID values are still the old ones. They're not the new ones. This can be frustrating if you're not sure what to do. So the solution is to go back out and go to Restore Failsafe. Once you click that, it will pull the new PID values from the firmware that you just wrote and write them to the EEPROM. Now you can go back and double check to make sure the new PID values are there. And voila! It's like magic. Now we do the final heat torque to ensure that none of that molten plastic escapes between the heater block and the heat break. And I've got a size 17 metric wrench to hold the heater block while I tighten it, and a size 7 so I can tighten the nozzle. After the hot end has got to 250C, then you can tighten everything down. You don't need to tighten this with the might of Thor, just get it hand tight and the heat will do the rest. Now we can finally print something! Haha! Let's do it! All the effort's gonna be worth it, the reviews are great, everyone loves this thing, it can't be beat! Yaha! What? What is this? Yeah, you forgot to adjust the Z height to account for the different length of the hot end. Duh. If you're an eager beaver just like me, you might have forgotten to adjust the Z height end stop switch. Also, don't forget to level that bed. This makes a huge difference. I know I've said this multiple times, but I can't preach it enough. If you don't get that first layer right, your prints are going to suck. Ooh, looks good to me. So you might have already kind of put it together that I really like E3D hot ends. I think that they perform great for the price. I think that they are amazing at understanding the thermodynamics and understanding the manufacturability of the different components and how they all come together in one assembly to make a top-notch hot end. If you think I'm just jumping on the E3D bandwagon and I'm getting paid by somebody, that's not the case. You can check out the video here and you can see how I made my own hot end called the Hyper Hot End. And I really tried to compete with E3D in both cost, manufacturability, and print quality. They kicked my butt, and I really do have a great appreciation for all the engineering and all the thought they put into these little hot ends. The community behind them, the marketplace, all the accessories that E3D has come up with, there's just an ecosystem that is very, very hard to compete with. They are by far one of the leading companies that creates hot ends in the 3D printing community. I've been using one for quite a while. I've used the V6, I've used the Volcano conversion, and I have been very impressed with the build quality and the community behind these products and the people that make them. Sanjay included, he was the one that kind of particularly reached out to me and said, hey, would you mind doing a review on one of our V6s? And so he sent me this V6 for free, so I wanted to tell you all that. I wanted to do this review and just kind of help everyone know how to put the one together and how to use it, and then also give some feedback to E3D themselves so that they could hopefully make a better product in the future. One of the things that I always run into is short cables, both the heater cartridge and the sensors, everything that goes on that has a wiring harness. It's too short for my Ultimaker, and it might just be Ultimaker specific, but I would appreciate longer cables so they don't have to create all these adapters and do all this stuff. And if they made a plug and play kit where I could just easily install it and have to do no soldering, that would be amazing. Also, the cooling fan on the hot end, the heatsink, it is crazy loud. It does a pretty good job blowing air, but if they could figure out a way to have a fan that was a little bit quieter, that would be great. The fan is now the loudest part of my entire printer. Those are the only two real complaints that I have about this hot end. Everything else is pretty spot on. And I wanted to thank E3D for the opportunity to help them make a better product. And that's the beauty of being open source. Anyone in the community can help make a better product with constructive criticism. I hope you enjoyed this video and learned something along the way. Don't forget to leave your comments down below, and then also hit the like and subscribe buttons. That helps me out a lot. I will see you next time. A quick update on the QX90. I reflashed it with Betaflight and put on Ladybird props. And oh my gosh, this thing is a whole new animal. You can fly it outside. You can do some amazing stuff with it. I had a great time flying it at my parents' house this past weekend. So stay tuned for more videos. I'm definitely going to be trying to see what modifications I can do to get the best possible flight characteristics out of this sweet, sweet little quad.
Ready.